So we notice 4 is positive, so he opens up. And that means the picture I'm looking at is something like this. That means he has the low point. There's your vertex. It's a minimum. And as we hit the application problems, that becomes important. And now we want to find the vertex. So the x-coordinate of the vertex is minus b over 2a, which is minus a minus 2 over 2 times 4, which is 2 over 8, or 1 over 4. Not fun. Now, just with that information, I can answer the axis of symmetry. Why? Because the axis of symmetry cuts the parabola in half. I know that the x-coordinate is 1/4. That says that axis is x equals 1/4. Because a vertical line is an x equal line, horizontal line is a y equal line. So axis of symmetry is y equals 1/4. So I'm at y. Oh, come on, Peterson. X equals 1/4. This is, I'm showing you how you can maximize your points, okay, as you go into an exam. Because I look at this thing and I'm saying, now what can I do? Well, I can do this by hand. And so that y sub v is going to be f of 1/4. Now, f of 1/4 is 4 times 1/4 squared minus 2 times 1/4 plus 1. If I am in a TIS situation, I pull my calculator out and let my calculator do the calculations. Why is that? Speed it up. And what do we need to do? Speed it up when we're talking about an exam situation. However, we're going to play the fraction game. 1 over 16 minus, I'm going to leave this at 2 over 4 plus 1. And I can look at a common denominator being 16. So 4 over 16 minus, this is 4 over 4, 8 over 16 plus 1, I multiply by 16 over 16, equals, this is 4 over 16, because 8 over 16, no, 4 over 16, and I have 8 over 16 plus 16 over 16, that gives me a plus 8 over 16, is 12 over 16. And 12 over 16 has a common factor of 4, so it's 3 over 4. What an innocent little number. I would have gotten 0.75 had I done it in my calculator, which is what I would have done. Now, what this tells me is if I'm going to do this stupid problem on the y's, I'm going to have on the y's, I'm going to have to scale my graph paper. Depends upon what my x and y intercepts are. So I'm not going to place my vertex on my graph paper. I'm going to find the x and y intercepts first. So x-intercept is where y equals 0. This is where 4x squared minus 2x plus 1 equals 0. This thing does not factor, because I need a 2 in the middle. And this says that the inner outers add together. So if I'm going to look at possibilities on this thing, it could be a 2x and a 1, a 2x and a 1, and this would be minus, and this would be minus. And that's going to give me a 4x in the middle, so that's not going to work. See, things are going to add together. That's going to make that middle bigger, not smaller. And I'm dealing with a 4 as a leading coefficient. Now, if it was a 4x, well, my only choice is 1. And an x, and my only choice is 1. Again, the signs are both minus. If I do the inner outers, I end up with a minus 5. So this sucker, that's my only two choices for factorization. It ain't going to work. Now, that means quadratic formula. So, using quadratic formula, A is 4, B is -2, C is 1, so that x is minus a -2 plus or minus the square root of -2 squared minus 4 times A, which is 4, times C, which is 1, all over 2 times A, which is 4. Now I've got another problem, and what's that? This is 4 subtract 16. What do I have? Negative. What kind of solutions do I have? What kind do I have? There's no real solution, right? But what kind do I have? If it's not real, it is imaginary. Yeah. So if I take a look at x-intercepts, there are none. That means this guy opens up and does not cut the x-axis at all. Y-intercept, I like him. He's the easy guy. And that's where x is 0. So that gives me 4 times 0 squared minus 2 times 0 plus 1, which is 1. So it's 0, 1. I have 2 coordinate points. I have the vertex and I have 0, 1. So this is what I'm going to do. I'm going to scale my paper, and I'm going to scale my paper so that I'm going to make this 1, and I'm going to, and I'm not, let's see, yeah, let's make this also 1. So that 1/4, 3/4, so that makes this is -1. That 1/4, 3/4 is going to be about right there. Because this is now a half, so between 0 and a half is 1/4. Probably should have widened it out. 0, 1 is right there. So that says I have half of my bowl. Now what could I do to get the other half? Which means I would use what? If I flip it, I'm using what idea? Begins with an S. Symmetry. So if I'm going to go that direction, I'm going to pencil in this is 1/4. That says in order to go from 1/4 to 0, I went how many units? 1/4, right? So that says that his mate is 1/4 over and 1 up. There's the other point. The other point is 1/2, 1, using symmetry. Now, I don't know about you. There are days that I'm not brilliant, and when I'm not brilliant, then what I then do is I do a T-bar chart, and I put the vertex in the middle. I have a point to the left of the vertex. If I want to get the parabola in, I need a point to the right of the vertex. Well, I'm not stupid enough, sometimes I am, but I'm usually not stupid enough to try to use a fraction. So what number might I choose so that's the right of 1/4? 1. And would 1 be an easy calculation? Yeah. I just need a point to the left, a point to the right, and then I join the points. That gives me the bowl. I can use symmetry, which is very nice, that's the flip it idea. So if I use f of 1, this is going to be 4 times 1 squared plus 2 times minus 2 times 1 plus 1, which is 4 minus 2 plus 1. 4 minus 2 is 2. 2 plus 1 is 3. Now I'm off my graph paper, because if this is 1, 1, 2, this is 2, 1, 2, this is 3. But do I care that I'm off my graph paper? No. So now I can graph the other half. And then what I know is that the arms continue to go up, and I can kind of finish that graph off. So all kinds of ways of coming at it. The problem tends to be when you don't have the x-intercepts, you've got to get another point, because you've got to get that U shape in. What college algebra is all about the graphing, and it's all about the functions. It's all about how they look. It's all about how they behave, because that's the only thing that makes math useful. So now we want increasing and decreasing, and we're going to go from, let's see, I'll use the red one, minus infinity to 1/4, because that's the x-coordinate of the vertex. I notice that the graph is going down, so this is decreasing. And then from 1/4 to infinity, the graph is going up, or y is going up. When I say the graph, I mean the y value. I have increasing. So then to answer the question all the way down at the bottom of the page, and I'll come back up again, is that it's increasing from 1/4 to infinity and decreasing from minus infinity to 1/4.
Any particular reason why you wouldn't include 1/4?
Because at that tippy top, it's absolutely flat.
Okay.
And then it's kind of like having something sitting there. It can tip either direction.
Right.
And so the question ends up being, what is it? Is it indeed, in fact, let's lose something that really is flat. Is it increasing or is it decreasing? Well, if it tips that way, decreasing tips this way, because you're really at the tippy top, and so it's really what you're looking at. It's more flat. Yeah, it's the high point. And then I'll move this back down.